In this video, we're going to look at the odd-even functions in trigonometry. The purpose of this is to get to some really cool ideas about equivalent answers and also slightly different answers based on the direction that you rotate around a axis system. Because when we do trigonometry, we're going to consider spinning around this origin from 0 degrees. And we can either do so in this direction. Let's say we move to 45 degrees in this direction. This would be a positive 45 degree angle. Going counterclockwise is considered positive. Going clockwise, like the hands of a clock, is going negative. So this would be considered negative 45 degrees. Now, is there a relationship between the 6 trigonometric functions of a positive 45 degree angle and a negative 45 degree angle? Well, let's kind of think of it this way. If I take the sine and go negative 45 degrees, so I'm looking at a sine value at negative 45 degrees at that location once I went that far along from 0 to 45. Is there something I can say about the sine value at this location? And to answer that, let's just kind of check out this filled out unit circle. So again, if you're kind of like new to my videos, you're probably going to be amiss to this full unit circle, although students in my class will have filled this out already, maybe even multiple times. So if we look at negative 45 degrees, which is here at 315 degrees, and we look at the sine value, you'll notice it's negative square root of 2 over 2. Well, this means that at the 45 degrees, it's exactly the same except it's positive. So maybe my hypothesis is, let me switch back again. My hypothesis is that the sine of negative 45 degrees is the same thing as the negative value of the sine at the positive 45 degrees. And this actually holds true for all of the other angles for sine if we go around this unit circle. So again, let's go back to this. Let's go to negative 60 degrees and look at sine. And if we go to negative 60 degrees and look at sine, here's negative square root of 3 over 2, and here's positive square root of 3 over 2. So these are just opposites of each other. Now, maybe you're thinking, well, it's just probably the first and fourth quadrant. Well, okay. Let's look at the third quadrant. Let's go negative 120 degrees. That takes me to 240 degrees. And again, if we go positive 120 degrees, you can see that the negative 120 degrees and positive 120 degrees is the same answer, square root of 3 over 2, except one's negative and one's positive. So this is true for sine. It's also true for the cosecants because the reciprocals are going to match, and we saw that in a previous video, that the reciprocals are going to have the same positivity and negativity values. So this means that since this is true for all values of t, my sine of negative t is going to be equal to the negative sine of t. And that's going to be the same for the cosecant as well. Negative t, and then negative cosecant of t. All right, now let's take a look at some others. Let's go look back here. I'm going to change colors here. I'm just going to look at tangent. So let's look at tangent at 30 degrees. Tangent at 30 degrees is square root of 3 over 3. Now let me look at tangent at negative 30 degrees, which puts me at this 330 degrees. Notice they're the same except they're the opposite. Whoa. What if I go a negative 100 and what if I go a negative, let's see, let me think, do my addition correctly. If I do a negative 150 degrees, it puts me at 210, and I'm going to look at that tangent value there. And I'm noticing that, oh wow, if I go the positive 150 degrees, these are exactly the same but opposite. Is that true for every tangent value? Look, I can see it there and there. And their corresponding spots up here. Notice how this -1 and 1, how these up above each other are opposites, and here, these are opposites. Is that true for every? Let's look down here. The tangent. Look at that, square root of 3, and up here, negative square root of 3. So it looks like the negative angle rotation is going to be the same as the positive angle rotation, except that the values are opposite again. And that will hold true for all the cotangent values as well. Look at all these cotangent values that are opposite of their positive and negative counterparts. Wow, it looks like just this is just turning out great. So here we have the tangent of negative t is equal to the negative tangent of t. And here we have our cotangent of negative t is equal to negative cotangent t. Now we're 6 minutes into this video. Something maybe should be burning in your brain a little bit, because you might be thinking to yourself, okay, why didn't you do cosine or secant yet? Like, that just seems like it's odd that you just skipped over those. Another thing that should be burning in your brain right now is wondering why these are called the odd and even functions. Like, seriously, why? What is the? It looks like this. All of them are opposites of each other. Just focus on these 4 relationships here. It looks like a negative rotation. So we're looking at the sine of negative t is equal to the negative sine of t. All right, just move the negative out front. I get this. But maybe you don't get it, because really, if we focused on, in this picture, if I went negative, look at my y value. My y value is here at some value, negative y. You can see that my y value would be positive here. So that kind of makes sense for sine and cosecant, because sine is, sine is y, and cosecant is the reciprocal of 1 over y. The tangent and cotangent also have y's in them as well. But here's where things get kind of messy, because I am going to bring up cosine. Now, cosine just has an x in it. So what if I go a negative rotation on cosine? Well, let's go back to my picture here for a moment. And this is going to be kind of a big whoa moment, because let's say I go negative 30 degrees, so my cosine is square root of 3 over 3. Or sorry, square root of 3 over 2. My bad. What if I go positive 30 degrees? Notice they're the same. They're exactly the same. Look at those yellows. They're exactly the same. So, okay, wait a second. This is getting weird. What if I go negative 90? Now my cosine is 0. Well, okay, go positive 90. Cosine is 0. Now, well, maybe negative 0's there. No, keep trying it here. Let's go negative 120 degrees, which takes me to this spot, and then go positive 120 degrees, takes me to this spot. Notice the x values are the same. So, going back to this page, you'll notice that the cosine of negative t is not negative cosine t. The cosine of negative t is just cosine of t. What's your hypothesis about the secant? What about secant of negative t? Maybe you want to pause the video and look back at that chart yourself. Well, if you haven't done that and you just want the answer, let's take a look at the green sections here. You go negative 30 degrees, 2 square root of 3 over 3. Positive 30 degrees, exactly the same. 90 and negative 90 are the same. And 120 and negative 120 are the same, because these are values of x. And since cosine and secant only have an x in them, oops, we don't need that, boop, then what we have is that the secant is t. So these are the odd functions. These are the odd functions. And these are the even functions. So in terms of the odd and even functions, we have 4 odd, where the direction of rotation matters. And the even functions, the direction of rotation doesn't matter. Now, wow, you're probably going like, what do you mean the direction doesn't matter? I thought it did. Well, in terms of its x value, it doesn't. So watch this spin. If I move in this positive direction, and then I draw an altitude, that's a geometrical concept of drawing a straight line down from a point. That altitude is at this location, that's a right angle there, and it's at this location, which I will make as a black big dot. Okay, see this black big dot right there? Well, let's take a negative rotation, so negative 45 degrees, and here I am at a at that spot, and I'm going to now drop an altitude, if I think of this around, from that 45 degree angles to this right angle. You see that the x values are the same. So if I go in this direction to 150 degrees, and I go this direction to negative 150 degrees, my x value is still, if I create an imaginary line between these two places where the terminal side ended, this spot here, this spot right here, it's the same x value. Now the y values are not the same. You'll see this is going to be a positive y and a negative y, but this x value right here is the same. That's why the rotation doesn't matter for your cosine and secant, because cosine is mapped to the x, and secant is mapped to the 1 over x. So since sine and cosine and tangent or cotangent all have a y in them, because again, this is y, this is 1 over y, this is y over x, and this is x over y, that's why the rotation matters, because the y is going to be positive or negative based on that angle of rotation. But the x is not going to matter, because the x is going to be the same no matter whether you go positively around the circle in a counterclockwise way or negatively in a clockwise way. Well, thank you for watching this video about the odd, even functions. It's fun.